This is a video to go over test number 3 review. So for question number 1, Rebecca and Cameron are arguing over which one correctly simplified the given expression. Determine if Rebecca or Cameron is correct and explain what the other did incorrectly by looking at their work. So let's take a look at what Cameron did. So the problem is cube root of 8x to the 5th over 27. So then Cameron broke the fraction up into the cube root of 8x to the 5th over the cube root of 27. And then for the numerator, Cameron factored out everything. So 2 times 2 times 2 gives you 8. And then there's also 1, 2, 3, 4, 5 x's. And then the cube root of 27 simplifies to 3. So then if we're looking at this, our index is 3, so we're going to pull out groups of 3. So there's one group of 3 2's and one group of 3 x's. So then x squared is going to be left inside. So we pull out a 2, we pull out an x, and we're left with the cube root of x squared. But Cameron does not have the index. So right off the bat we know Cameron's wrong. So now let's take a look at what Rebecca did. So same problem, cube root of 8x to the 5th over 27. Then Rebecca broke it up into exponents, or well, the factors with exponents. So 2 to the 3rd, which is 8, times x cubed times x to the 2nd power. So we know that x cubed times x to the 2nd power gives us x to the 5th because we add exponents, and 3 plus 2 is 5. So that's correct. And then she broke 27 down into 3 cubed. So that's correct. So she factored everything correctly. So now let's take a look at her next step. So then she put parentheses around everything with an exponent of 3 and pulled the exponent of 3 out, and then she's left with times x squared. So that part's correct as well. So let's look at her next step. So then she broke the radical into the cube root of the quantity 2x over 3 cubed times the cube root of 2x squared. So that part's right because of the property of radicals, which says if you're multiplying under the radical, then you can break it up into 2 radicals. And then lastly, she simplified this portion right here. So if you are cubing something and then you take the cube root of it, then the cube and the cube root cancel and you're left with 2x over 3. So she's left with 2x over 3 times the cube root of x squared. So Rebecca's answer is completely right. So let's go back and explain what Cameron did wrong. So Cameron's answer would have been right had she remembered her index. So Cameron is incorrect because she forgot the index of 3. Other than that, her answer would have been right. Alright, so now let's take a look at number 2. Alright, so we have the cube root of 75 x to the 9th, y to the 8th, z. Alright, so let's see if we can factor 75. So 75 is 3 times 25 and then 25 breaks down into 5 and 5. We do not have any groups of 3, so we can't do anything more with that. We have 9 x's, so I'm going to write them out. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 8 y's. 1, 2, 3, 4, 5, 6, 7, 8, and 1 z. So I'm going to circle all the groups of 3. So there's one group of 3, another, and another. Alright, so now we can go ahead and write our answer. So there's 3 groups of 3 x's, so an x cubed is going to come out. We have 2 groups of y's, so y squared is going to come out. We don't have any other groups, so everything else stays under the radical. So we still have 75. We have 2 y's and 1 z. So that would be our final simplified answer. Alright, so let's take a look at B. To add radicals, the radicands must all be the same. They are not, but they can be simplified, so we're going to go ahead and simplify them and see what we get. Alright, so 12 breaks down into 3 and 4. The square root of 4 is 2. So this simplifies into 2 square roots of 3. With 48, that breaks down into 3 times 16. 16 is a perfect square, so square root of 48 simplifies to 4 square roots of 3. And then square root of 27, 3 times 9 is 27. Square root of 9 is 3, so minus 3 square roots of 3. So now they all have the same radicand, so we can go ahead and add and subtract. So 2 plus 4 is 6, minus 3 is 3, so our final answer is 3 square roots of 3. Alrighty, so let's take a look at letter C. So in letter C, we're going to have to double distribute. So 3 times 2 gives us 6. 3 times the square root of 6 gives us 3 square root of 6. Remember, when we multiply what's on the outside of the radical and what's on the inside of the radical. So there's an understood 1 right here. So 3 times 1 gives us 3 square root of 6. And then same thing for square root of 7. So 2 times the square root of 7 would give us 2 square root of 7. And then when we're multiplying radicals and there is no coefficient in front, then it's just we multiply the radicands together. So square root of 42. Alright, so now we're going to look to see, can we simplify square root of 42. So 42 breaks down into 6 and 7, 2 and 3. Can't do anything with that, so that is our final answer. Alright, so let's take a look at D. So when we are dividing radicals, we cannot have a radical in the denominator, so we have to rationalize by multiplying by square root of 7 over square root of 7, because we want to get rid of this radical in the denominator. So 3 times the square root, or 3 times the square root of 5 times the square root of 7 gives us 3 square root of 35. Square root of 7 times the square root of 7 gives us 7. We can't break down the square root of 35, so that is our final answer. Alright, so letter E is just like D, except we can go ahead and simplify somewhat. So the square root of 25 is 5, so a 5 comes out. Square root of a squared is a. We don't have a pair of b's, so b stays under the radical. So now instead of having to multiply by the square root of 25a squared b, we just have to multiply by the square root of b to get rid of the radical. So then negative 2 times the square root of b gives us negative 2 square root of b over 5a square root of b times the square root of b gives us 5ab. So then that's our final answer. Alright, so for f, it's a little different. We don't just multiply by the radical, we multiply by the conjugate of our denominator. So in this case, the conjugate is 6 minus 5 square root of 6. So what we multiply by the numerator, we have to do to the denominator so we don't change our expression. So now we're going to double distribute. So 4 times 6 gives us 24. 4 times negative 5 square root of 6 gives us negative 20 square root of 6. Negative 8 square root of 3 times 6 gives us negative 48 square root of 3. And then lastly, negative 8 square root of 3 times negative 5 square root of 6 gives us positive 40 square root of 18, because 3 times 6 is 18. Alrighty, and then over 6 times 6 gives us 36. And then since we have a plus and a minus, but our a and b terms are the same, then that means that we won't have a middle term. So in effect, we'll just be squaring the first term and then squaring the last term. So 5 times 5 gives us 25, but it's plus and minus, so it's going to be minus 25, and then square root of 6 times square root of 6 is 6, so minus 25 times 6. Alright, so now let's check our numerator to see if we can simplify anything. 24 doesn't simplify, 20 square root of 6 doesn't simplify, negative 48 square root of 3 doesn't simplify, but 40 square root of 18 does. 18 can break down into 9 and 2, so square root of 9 is 3, so we're going to multiply this 40 by 3. So we're going to get 24 minus 20 square root of 6 minus 48 square root of 3 plus 40 times 3 is 120 square root of 2 over 36 minus 25 times 6 is negative 114. We cannot have a negative in our denominator, so we're going to change this to a plus and distribute a negative to the top. So then we're going to get negative 24 plus 20 square root of 6 plus 48 square root of 3 minus 120 square root of 2 over 114. We can take out a factor of 2 from everything. So negative 24 divided by 2 gives us negative 12. 20 square root of 6 divided by 2 gives us 10 square root of 6. 48 square root of 3 divided by 2 gives us 24 square root of 3. Negative 120 square root of 2 divided by 2 gives us negative 60 square root of 2 over 114 divided by 2 gives us 57. So our final answer would be this. So we took out a factor of 2 out of everything. Alrighty, so that covers the simplifying radicals portion of the test review. So I'm going to conclude this video and do number 5 with the solving in a different video.